So this is the code for decision tree and random forest simulation. Let's take a sample data set. Right now we'll going for regression data set. This is for regression. We are choosing randomly all the feature columns, and this is the target column. We can change it according to our need. According to this column, everything will be splitted in the decision tree. This is showing the mean squared error right now. We can also change the error. These are the criteria used. Like, there are different kind of errors. Right now we are going for squared error, as mostly it is used. And the splitter, it is as random and best splitter according to the size of the data set we are choosing, because randomly splitter are doing very fast splitting. So for that we have to use random, but right now we are using best. These are the minimum sample split, sample leaf, and max depth. Right now we have kept max depth 3, and we can change it so you can see the actual decision tree. Every decision tree has squared error and samples and values. Mean squared error, as we are performing regression in decision tree right now. And then we'll go for the random forest. For random forest, there are number of trees in the random forest, and minimum and max features. There are three types of max feature selecting. Right now we are using square root of features, and this is the minimum sample split. Max depth is 3, we can reduce it. And there are number of trees we can select for the visualization. Right now if we are selecting 48 trees, it means we are averaging all the 48 trees and going for one random forest tree. These are the theory you can refer if you want to change all the hyperparameters and learn how to do it. And since it is showing right now mean square error, now we'll go for classification as well. For classification, we have to use a different data, that is of binary classification. This is the pre-processed data right now. We are choosing features randomly. And for the target column, we have to choose something which is having binary classes, that is 0 or 1. So let's say this is the binary class. This is the random forest, and you can change the number of forest. You can see the Guinea impurity and samples and values. Since we have here the criteria of Guinea impurity and entropy, we can change it according to whatever we want to. And we can also, since this is for classification, we can also perform decision tree classification. Let's go for decision tree. This is the decision tree visualization. We can simulate it by changing the parameters here. Right now we are doing with Guinea impurity. Let's do it with entropy. Here you can see that it is have changed. And decision tree are having accuracy as their performance parameter. So these are this is the dataset preview of whatever data we are keeping. That's all. Thank you.